Okay, welcome back. We are now in section 3.3, and 3.3 deals mainly with the zeros of the polynomial. So if you remember, when we talked about zeros, we said that the zeros, the factors, and the x-intercepts were all related. And we found those from using each one from the polynomial. So if we know the zeros, we can write them as factors or write them as an x-intercept. If we know the factors, we can write them as zeros or write them as x-intercept. That was in section 3.2. So now we're going to be focusing on the zeros. So the first thing we're going to look at is the multiplicity of a zero. And multiplicity means basically how many times does each zero occur? Or how many times, if you want to think of it another way, how many times does each factor occur? So basically, they're going to ask you to find the zeros and state the multiplicity. You can see that in the question right here. So they've already factored this for us, and we can easily find the zeros. So remember, whenever you have an x by itself, that zero is x equals 0. For x minus 2, that would be x equals 2. And for x plus 3, that would be x equals 3. I'm sorry, negative 3. So remember, when there's a number in your factor, you can easily think of it as the opposite of whatever sign is here. So the opposite of minus 2 is 2. The opposite of plus 3 is minus 3. So the multiplicity is basically, in this case, the exponent on the factor. So x squared happens twice. So the multiplicity here is I spelled that right. No, not quite. Let's try that again. Multiplicity. Well, anyway, the multiplicity is 2 because the exponent is 2. So the factor of x occurs twice. The factor of x minus 2 only occurs once, so the 0, 2 is only going to occur once. And x plus 3 is squared, so that occurs twice. So the multiplicity of negative 3 is a 0 is 2. So that's all you're going to have to do with these problems. They're fairly simple. Just be careful. It's going to ask you off to the side or remind you whether to put the lowest value of x in a certain box or the highest value of x in a certain box. So pay attention when you're doing these problems in WebAssign. Again, all you're doing is finding the 0 from the factors and then stating the multiplicity, which is the exponents on each one of these. And when there's no exponent, it's the same as a 1 for your multiplicity. Okay? All right, so let's move on. Our first theorem we're going to use here is the rational zero theorem. So here's what's going to happen. Before, when we had to factor the polynomial and come up with the graph and come up with the intercepts, it factored really nicely because we could take out an x or an x squared first. But now we're going to be dealing with ones that aren't going to factor very nicely. We're going to have to do long division. So we want to know what numbers should we use for long division. So the rational zero theorem gives us basically a possible list of all the zeros. So we're looking for what numbers are possibly ones that we should use, because before we start this, we have an infinite number. We could use 1, we could use 500, we could use negative 3 million, 200,567. There's a whole bunches of numbers, but we want to narrow it down to just a small list. So this is going to narrow it down to a smaller list of possible zeros. And you can see the ratio we're going to use is P over Q. So let's take a look at where those come from. P, we're going to find the factors of P. P is the factors of the constant term. Constant term is the term with no variable. Q, we're going to find the factors of Q also. Q is the factors of the leading coefficient, or the first coefficient with the highest exponent. Okay? And we're going to write out all of those factors, and we're going to list them in fractional form, all the factors of P divided by all the factors of Q. Okay? So let's take a look and see how that actually works. So list all the possible rational zeros. So first off, let me label this. So P we said was our constant. That's this 8. And the sign doesn't matter. I'll show you why a little bit later. And Q is the leading coefficient, which would be this 3. So we want the factors of P divided by the factors of Q. So the factors of P, or the factors of 8, are 1, 2, 4, and 8. Okay? And the factors of 3 are 1 and 3. Now, I said the negative doesn't matter with this 8. Here's why. If we multiply 1 times 8, we get 8. If we multiply -1 times -8, we get 8. Or -2 times -4 is +8, or 2 times 4 is +8. So we could use all of these numbers, 1, 2, 4, and 8, as well as -1, -2, -4, -8. So when we're done, we're going to list the factors of P, all divided by the factors of Q, and then we're going to say it's the positive one and also the negative one. I'll show you how that works. So we're going to take the factors of P, and if you want to label these, this is P, this is Q. So we're going to take each one of these and divide them by 1. So that would be 1, 2, 4, and 8. If we divide by 1, we get the same thing. And then we're going to take each one of these and divide by 3. So when we divide 1 by 3, we get 1/3. 2 divided by 3 is 2/3. 4 divided by 3 would be 4/3. And 8 divided by 3 is 8/3. So notice I'm leaving these as fractions. You want to leave them as fractions because, again, if I divide this and write it as a decimal, it's going to be a decimal that goes on forever. And we don't want to round it. We want the exact number. So leave it in fraction form. So it is all of these plus it is also all of these. -1, -2, -4, -8, -1/3, -2/3, -4/3, and -8/3. So let me tell you the bad news. Unfortunately, this is one of those problems in WebAssign that it's got a nice long answer, because you're going to have to type in every single one of these numbers all the way out. Okay? If it were me, I would put 1, then -1, 2, then -2, 4, then -4. So that way you can look at your list and make sure you didn't miss anything, because each positive and negative one are matched up with each other. Okay? All right. Let's take a look at the second one. Same thing. This time, though, P and Q have a little bit more factors than we had last time. So let me just stop and go back real quick. This whole entire thing is your answer. So remember, we're looking for possible zeros. So we just narrowed it down from infinity to this smaller list. And remember, the highest exponent tells us how many factors there are, or how many zeros. So there's only 4 of these that are actually going to work. So we're going to use synthetic division later to narrow this down to a smaller list and get exactly the 4 that do work. Okay? But now we have a smaller list at least to work from. Okay, let's look at number 2. So again, label your values. 18 is P, 4 is Q. And the factors of 18 would be 1, 2, 3, 6, 9, and 18. And the factors of 4 would be 1, 2, and 4. Now, when you list these, when you start dividing by 2 or dividing by 4, some of these numbers may be equal to something we already have. So you don't want to list the same thing twice. So keep that in mind as you're doing these. So the easy one is 1. So when we divide all of these by 1, again, it's P over Q. All of these divided by 1 is just the same number. So we've got I'm going to just write a plus or minus at the beginning, so we know it's plus or minus. But again, this isn't in WebAssign, so you've got to write them all out like we did here when you do this in WebAssign. So 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1, 9 divided by 1, 18 divided by 1. Okay? Now we're going to take all of those and divide by 2. So 1 divided by 2 is 1/2. 2 divided by 2 is 1. Well, we already have 1, so we don't need to list it again. 3 divided by 2 is 3/2. 6 divided by 2 is 3. We already have 3 here, so we don't need to list it again. 9 divided by 2 is 9/2. And 18 divided by 2 is 9, which, again, we already have. So we don't need to list 9 again. All right, now we're going to divide by 4. So 1 divided by 4 is 1/4. 2 divided by 4 is the same as 1/2. So we don't need to list that one again. Okay. 3 divided by 4 is 3/4. 6 divided by 4 is the same as 3/2. 9 divided by 4 is 9/4. And 18 divided by 4 is the same as 9/2. So we don't need to list that. So here's our possible list of the possible zeros for number 2. So when you're asked to list the possible zeros or list the possible rational zeros, it's going to look just like this. You're going to make a list. So there might be 6, there might be 12, there might be 24, but it's a whole lot better than infinite. Okay? All right, so that's the first thing. Second thing is narrowing down this list a little bit more, or figuring out which one of these should we try first. And the way we do that is using something called Descartes Rule of Signs. Okay, so this helps us determine how many positive and how many negative real zeros will be in the polynomial. So we said that when 1 is a 0, it could be 1 or it could be -1 or 2 or -2. Now we're going to figure out how many of those of the total number that we need. So if we need 4 zeros, how many of those are going to be positive and how many of them are going to be negative? Okay, so, and this is kind of simple because all we're going to do is count. So we're counting the number of sign changes in the polynomial. So we're going to take the polynomial just like it is, count the number of sign changes, and that is going to give us the number of positive zeros. Okay, now the zeros could be duplicated. So we're going to take that number, whatever we get, and we're going to decrease it by multiples of 2. So we're going to subtract 2, and then we're going to subtract 2 again. And if we can, we'll subtract 2 again until we get down to either 1 or 0. I'll show you how that works. Okay. Then we're going to count the sign changes to get the negative zeros. So for the negative zeros, we have to replace x with negative x. Now, this says replace x with negative x and simplify, but I'm going to show you a simpler method to do that works a whole lot better, okay? And it'll save you some time. So let's take a look at this first one. Find the number of real zeros, positive and negative real zeros. So I listed each one twice because we're going to use the first one for positive, and we're going to use the second one for negative, okay? So for the first one, we're just going to count the sign changes. And notice this one goes from x to the 6th to x to the 3rd. It doesn't matter if there's any missing ones when we do this method. We're just looking at when does the sign change. So from 3x to the 6th is positive, and we still have a plus, so the sign didn't change. Now we go from a plus to a minus. So there's one sign change, minus 16x squared. Then we go from minus 16x squared to plus x. There's another sign change. And then from plus x to minus 15. So there are 3 sign changes. That means there are 3 positive zeros. Or we're going to subtract 2, or there's 1 positive zero. Because again, there's a possibility, we don't know yet, but there's a possibility that one of those could be a duplicate 0. So we won't count it twice if it's the same number. Okay? All right, then we're going to put in negative x. So here's the shortcut. If I put a negative x in when it's x squared, I still get x. So if I have 3x squared and I put negative x in, I'm still going to get 3x squared. So it's not going to change the sign. It's still going to be positive. But if I put in, let's say I had 2x to the third, if I put in negative x into that, so 2 times negative x to the third, that's going to give me negative 2x to the third. That will change the sign. So when you're doing the negatives, what we're going to do is we're going to change signs, if I could spell today, on odd exponents. Let's hope that shows up right. Change signs on odd exponents. There, perfect. So that means this plus 7x to the third is going to change to a minus. I'll put a minus there. Big minus. The x squared is going to stay the same. The x, which is x to the first, that's odd, so that changes to a minus. And there's no x here, so that stays the same. So now we're going to count the sign changes. So from positive 3x to the sixth to negative 7x to the third, there's one sign change. And then we're negative to negative to negative to negative. It doesn't change again. So that means there are 3 or 1 positive zeros, and there is 1 negative zero. So again, count your sign changes for the polynomial just the way it is. Remember to subtract 2 till you can't subtract 2 anymore. So if you counted 4, you would have 4, 2, or 0. Okay? And then change the sign on the odd exponents. This one is odd. This one, because it's technically 1, put a 1 there, is odd. And then count the sign changes again. That gives you your negative ones. And again, if this were 2 or higher, we would subtract 2 till we couldn't do it anymore. All right, let's look at another example. Number 2 down here. So we have one sign change here from x squared to negative 16x. And then from negative 16 to positive 15, we have a sign change. So our positive zeros is, there's 2 of them, or there could be 0. Okay. We're going to change the sign on the odd one. So this 2x to the third becomes a negative. This 16 becomes plus. So the sign changes there from negative to positive, and it stays positive. So negative zeros, there's only 1. Okay. So now that I know how many positive and negative zeros are, let's go back to our previous list that we were using. I can take this list, and if I need only 2 positive ones, I don't need to check all whatever there is, 16, 12 numbers. I can check till I get 2, and then I can stop on my positive numbers, and then I can look for 1 negative number. So that narrows down the list even more to our exact list that we need to solve. Okay? All right. So how do we use this? Well, zeros are the polynomial. So here's the steps of determining the zeros. First, we're going to figure out how many should we have. That's, again, the highest exponent in our polynomial. Then we're going to find out how many positive ones and how many negative ones we should have. We just did that. Then we're going to use the rational zeros theorem to do P over Q. And finally, we're going to test the zeros using synthetic division. And I'll show you a couple things to do with that. Now, we only have to do that until we get down to 3 terms, because 3 terms is a quadratic, and we can factor the quadratic. Or if we absolutely have to, we can use quadratic formula to get the remaining zeros. Okay. Now, some of these that we do, they're going to have real zeros, which means they're whole numbers or rational numbers. Some of them are going to end up with complex zeros, which means we might have I in the problem. And we'll see how that works out. All right, let's take a look at one of these examples. So here's our polynomial. Find the zeros, and they want us to create a rough sketch of the graph. So this is a little bit of what we did in section 2 as well. So first off, we're going to count the sign changes. So I've got 1 sign change and 2 sign changes. So for my positive zeros, I should have either 2 or 0 of those. Okay. Let's change the sign for the negatives. So for my negatives, this x to the third is going to become negative. This 5x is going to become positive. So that we have 1 sign change right here. So for my negative zeros, I only have 1. Okay. Then we need to list p over q. So p is 6. Q is just 1 because there's no number in front of x cubed. So p over q really is the factors of 6 divided by 1. So it could be plus or minus 1, 2, 3, or 6. Okay? And now we're going to use synthetic division to test and see which one of these work. So remember, with synthetic division, you're going to use only the coefficients. Now, there are 4 positive ones and 4 negative ones. So I have 8 different numbers to check. So I could try the first one and it doesn't work. And then the next one doesn't work. And then the next one doesn't work. So I could sit here all day trying these different ones and see which ones work and which ones don't work. So sometimes you have to do that. It's kind of like guess and check. But there is one shortcut with synthetic division. Okay? And let me show you what that is. So if all coefficients add up to 0, then the number 1 is a 0. Okay? That's the only, this should say is, that's the only shortcut I'm aware of for synthetic division. So before I start checking all these, I'm going to add these numbers together to see if they add up to 0. If they do, then I know if I use 1 with synthetic division, it will work. So remember, we're looking for which one of these are zeros. That means we have to get 0 for the remainder. Okay? So 1 plus -2 plus -5 plus 6, well, that adds up to 0. -2 plus -5 is 7. 1 plus 6 is 7. 7 minus 7 is 0. So that means 1 is going to work. So let's do synthetic division with 1. So we're going to bring down the 1. 1 times 1 is 1. Add that together. If you want to write a plus sign there, you could. 1 times -1 is -1. Add that together. And 1 times -6 is -6. And we're left with 0. So my first 0 is x equals 1. So we're down to 3 terms. When you get to 3 terms, you're going to write out the polynomial. X squared minus x minus 6. And if you can, now you can factor it to get the other ones. So you don't need to continue doing synthetic division over and over and over again. When you get down to 3, you can write out the polynomial and factor. And this one factors, so we got x minus 3 times x plus 2. So if we solve this, x is equal to 3 and -2. So my other zeros are 3 and -2. Now, do I have all the zeros? How do you know that? Well, let's go back up to the top. Let me highlight this first. If we look at our original polynomial, the highest exponent was a 3, which tells us there should be 3 zeros. We got 3 zeros, so we're good to go. Okay? All right, so they want us to do a rough sketch of the graph. So remember, these 3 zeros are also the x-intercepts. So I got an x-intercept at 1, I got an x-intercept at 3, and an x-intercept at -2. Okay? So remember, from section 2, we're going to look at our first term. Our first term is positive. I'll write that over here. And the exponent is odd. That means this one's going to go down on the left and up on the right. So My graph from the left side goes down. My graph on the right side goes up. I already got my 3 zeros. Each one of them only happens one time. So that means that all 3 of these points, the graph is going to cross. And finally, if I go back up here to my polynomial, looking at the polynomial, the last number is a 6 all by itself. That means 6 is the y-intercept. So my y-intercept is up here. So I've got to go all the way up to 6 and cross at 6. So from here, I should probably make this a little bit better because it's going to kind of go like this. Comes up to 6, comes back down to 1 and crosses, and then back up and crosses at 3. So there's our sketch. Okay, so we found the positive and negative zeros by counting the sign changes. We listed P over Q to get the possible zeros, and then we tested those in synthetic division to see which ones work. So if you test a number, let's say we didn't have a shortcut and we tested 1 and 1 didn't work, then we would try 2, or we might try -1. So you want to use the smaller numbers first before you start getting up to the 3 and the 6, because that's just going to give you really big numbers in your synthetic division. Okay. All right, let's try one more. So same thing here. Oh, this one actually ends in a 6 too, so it's going to be kind of similar. So first we're going to see there should be three zeros. That's from the highest exponent. There is 1, 2 sign changes. So that means there are 2 or 0 positive zeros. Okay. If we change the odd ones, this is going to become a negative. This is going to become a negative. So there's only one sign change here. So there is 1 negative 0. Okay. And again, we're going to do P over Q. So P is, sorry about that, P is 6. Q is 1. It's kind of nice again. So P over Q is the factors of 6 divided by 1. So 1, 2, 3, and 6. And same thing, now we can do synthetic division. So we got 1, -4, 1, and 6. So if you look at these, 1 minus 4 plus 1 plus 6, that doesn't add up to 0. So that means positive 1 does not work. So we don't even need to check positive 1. Okay? So let's start off with -1. So if I do -1, we're going to bring this down. -1 times 1 is -1. Add those together, we get -5. -1 times -5 is +5. That adds up to 6. And -1 times 6 is -6. So our first 0 is -1. So that is our -0 that we were looking for. There's only one of them. That means our next 2 zeros have to be positive. Okay? So we got 3 terms left. We can factor. So we got x squared minus 5x plus 6. And that gives us x minus 3 times x minus 2. And that gives us x equals 3 for one 0 and 2 for the other 0. Both of them are positive. So here are our, whoops, I need a comma there. Here are our 3 zeros. Again, remember, those are also the x-intercepts on the x-axis. So we got -1, we got 2, and we got 3. And again, with this one for our graph, x to the third is positive and the exponent is odd. So our graph is going to go down on the left and up on the right. And again, our y-intercept is +6. So very similar graph, just a little bit different x-intercept. So again, we're crossing here, we're going up to 6, back down to 2, and it's going to cross, and back up to 3 and cross there. So again, let me point out how ugly my graph is, but again, it's just a sketch. The important thing is that your points for the intercepts are correct, and your left and right behavior are correct. So these are the important things on your graph, as well as the left behavior and the right behavior. And again, we didn't have to worry about it this time, but whether the intercepts cross or touch is also important when you're doing these, okay? All of these crossed, so we didn't have to worry about it. All right, so that is section 3. Be sure and practice with your homework problems. If you need additional practice, let me know. Don't forget you have your personal study plan that'll give you some extra problems. And I will see you in the next section. Have a great day.